Good afternoon, my wonderful chemistry students. Today is video number 6. We are going to delve into concentration. We are going to be able to calculate concentrations for various solutions using the equations in table T. Yes, concentration in chemistry means something a little bit different. It is the amount of solute relative to solvent in a solution. There is a few different kinds of concentration that we must be able to use. I do want to see your work on this, so let's start by going to table T and defining these formulas. Table T is the last page of our reference tables. Molarity. Molarity is the moles of solute, the stuff that's being dissolved, over specifically liters of solution, liters of the total solution. So it says, what is the molarity of a solution that contains 4 moles of NaOH in 0.5 liters of solution? So it's a pretty easy calculation. I'm going to take the moles, 4 moles, and I'm going to put that over 0.5 liters of solution. And 4 divided by a half should be 8. Capital M is what we call molar. 8 moles per liter, or 8 molar, capital M. Parts per million is a little bit different. Parts per million is also on here. It is the mass of the solute, or the stuff being dissolved, that's what solute is, over the mass of the solution. Now remember, in both of these, the solution is the solute and the solvent mixed together. So it's going to come into a play here. It's not going to be that much different, but let's see. I have 0.0043 grams of oxygen, and it says it can be dissolved in 100 milliliters of water. Express this in terms of parts per million. Well, milliliters is volume, not mass. Problem. Well, being that it's water, it's actually not that big of a problem, because I know that water is got a density of 1 gram per milliliter. The density of water is 1. So if I have 100 milliliters, that should equal 100 grams. So there we go. But the problem is this. I put this much solute in there, so the number is actually going to change slightly. It's going to be 100.0043 grams of solution. You got to do it like that. It does change the calculation ever so slightly, but not very much, to be honest with you. Oh, and then I have to take that whole thing, and what I did forget on the top, I apologize, I have to multiply by 1,000,000. 2, 3, 1, 2, 3. I'm going to multiply this whole thing by 1,000,000. 3, 2, 3. I count the zeros out. Okay, so I get in my handy dandy calculator 0.0043 divided by 100.0043 equals times 1 with 1, 2, 3, 4, 5, 6 zeros equals 42.998 ppm, parts per million, and I can say that's basically 43 ppm. Bam, 43 ppm. Good. Those are our 2 major calculations we need to be able to do. Percent by mass and percent by volume. These are not in reference table T. I'm going to give them to you. They might be a little bit in the notes, but you're probably not going to see too many of these on the test. So percent is always part by whole. So percent by mass is going to be mass of solute over mass of solvent. Volume, again, percent is part over whole. So this is going to be volume of solute over volume of solvent. And of course, oh, it is percent, right? So I have to multiply both of them by 100. Okay. Let's see. Now, that's the percent by mass. Oh, wait. So I think we just need to fix this. Let's do, instead of solvent and solvent. Sorry about that. Let's do solution. It is part over whole. So it makes sense that it should be solution. Solution. Now, to be honest with you, I haven't checked ahead to see what the answers are, but I just want to make sure I don't make it have it be wrong when it comes time. So let's see. This is going to be 2.5 grams over 52.5 grams. That's the part over whole, right? And yeah, I got to add the 2.5 onto the 50 times 100. Well, let's see. I haven't peeked yet, so let's see if I got this one right. 2.5. Oopsies. 2.5 divided by 52.5 equals times 100 equals. I have 4.76. 4.76%. See what it has here. 4.76%. Mr. Milk's definitely volume of solution and mass of solution, part over whole. Makes sense. All right, so in this case, my part is the 50 milliliters. My whole, though, is now going to be 350 milliliters because I have 300 milliliters of solvent. Oops. It says to form a total volume of 300. So Mr. Milks, read carefully, please. It's not just 300 milliliters of water. It says diluted with water to make a total of 300 milliliters. That's what I need is the total. So now it's 50 divided by 300 equals times 100 equals 16.67%. We can call it 16.7 if you want. Beautiful. 16.7%. That's it. Now we know how to calculate 4 different kinds of concentration. The first 2 are going to be the most important. We can do a little bit of practice packet right here, pages 13 through 16 to get some practice on that. But there's no CASEL yet. The next CASEL quiz will be after the next homework video. So be well, study hard, and I will see you guys tomorrow in class.